We're now going to be shifting into the course where we're going to be learning new material for all students, whether you've taken 10 academic or 10 applied. We're going to be looking at a new type of graph, which are called sine functions. But before we get to sine functions, we're going to talk about a periodic function. So in this example, the question is this graph periodic? This demonstrates what we call a periodic graph because a periodic graph has a pattern that repeats. So it doesn't matter where it starts. It could start from here and it would be up, up, and then a little bit down, and then a little up, way down, a little up, little down. So that could be one pattern. Or you could almost say the pattern starts here and you'd almost have like this tooth looking. Doesn't matter where it starts. The whole idea is that a graph is periodic if there is an exact pattern repeating. Now we're going to be going over a whole bunch of definitions. So you can see here, a graph is periodic if there is an exact pattern being repeated over and over again. So the next thing you need to know is what a cycle is. A cycle is the pattern that is being repeated. So this here, right there, is the cycle. And the period is the length of the cycle along the x-axis. So from here to here, that is a cycle. And the length of that cycle is 1, 2, 3, 4 units. So the period is 4 units. If the units aren't provided, you just say units. Here's another cycle. And here's another one. That's the whole idea of what makes it periodic, is that it is a cycle repeating over and over again. So the period is the amount of the domain, which is the x values that it takes to complete one cycle. The maximum is the highest y value and the minimum is the lowest y value. So the maximum is actually right up here. And that would be at about 2.5 units. The minimum is down here, and the minimum is at -2 units. The next thing you need to know is what the axis is called. The axis is center line that runs horizontally right in between the maximum and the minimum. So the formula to find the maximum is max plus min divided by 2. Now the maximum is sometimes called the D value. So you could say that the D is the maximum plus the minimum divided by 2, and the maximum is 2.5, and the minimum is -2, and we divide that by 2, and 2.5 plus -2, so the plus minus makes a negative, so that becomes 0.5 divided by 2, which is 0.25. Now that is the average halfway in between the maximum and the minimum. So that means your axis is the horizontal line that is right in between the maximum and the minimum. So this is the axis. And because it's a horizontal line, its equation is y equals 0.25. It's really important when you give what the value of the axis is, that you give it as an equation, y equals 0.25. So the equation does not actually have the d. The d just tells you what the halfway point is between the maximum and the minimum. And later on, when we learn how to find the equation of these, what we call sine functions, that's where you need to know the d. So the d is just telling you where the halfway point is, and then the halfway point is the axis, and it becomes an equation, so you have to put a y equals in front of it. And the next thing, or the last part of definitions that you need to know, is the amplitude. And the amplitude is the distance from the axis to the max, and it's also the same as the distance from the axis to the min. So here is the axis. If you take that up to the maximum, that is the amplitude. And that is the same as the distance from the axis down to the minimum. So that's exactly the same distance. And the formula that you would use to find the axis is max minus min divided by 2. And that value is using the letter A. And A will come into the formula later on. We're not going to get into using a formula today. So max minus min divided by 2. So the maximum is 2.5. Subtract the min, which is -2, divided by 2. And when you subtract a negative here, this becomes a plus. So 2.5 plus 2 is 4.5 divided by 2. And that makes 2.25 units. So that is the amplitude. The next thing is domain and range. So the fact that the graph goes all the way to the left and all the way to the right indicates that it keeps going. So the domain would be XER. Remember that E isn't really an E. It's kind of like a C with a line through the middle, and the R is a capital letter. For the range, just like before, the furthest it goes down is -2. The highest it goes up is 2.5. So for the range, the y is in the middle. The minimum is -2, so that goes on the left. The maximum is 2.25, so that goes on the right. And then you write YER afterwards. The YER means that there's no breaks in the graph. There's nothing missing between -2 and 2.5. So those are the definitions you need to know. The next thing that we would be going over is a question like this. What is the value of f of 2? So we've done function notation in Unit 2. This is just asking, what is y when x equals 2? What is y when x equals 2? So when x is equal to 2, right here, you can see that the point there has a y value of -2. So that means f of 2 is equal to -2. So that's just basically saying when the x is 2, the y is -2. So similarly, what is the value of f of 5? Well, here's 5 here. Here's an x value of 5. And when x is equal to 5, the y value is equal to 2. So f of 5 is equal to 2. And it's asking what is f of 9? So 9 is right here. So the y value when x is equal to 9, again, is 2. So f of 9 is equal to 2. Now, what is f of 13? So when x is 13, your y, the point is here, and the y value, again, is 2. So the question is asking, why do you think you get those results? Why is it that the y value is always 2? And that's the whole point of this being a periodic function. Is a periodic function, the pattern repeats itself, and the period is 4, which means the pattern is repeating itself every 4 units. So whatever this value is, 1, 2, 3, 4 units later, it's going to be the same. 1, 2, 3, 4 units later, it's going to be the same. So the reason why it does that is because these are all 4 units apart. The period equals 4, which means the cycle repeats every 4 units. Now, what makes this question important is when you get a question like this. What is the value of f of 38? Well, this graph only goes up to, there's 13, so this graph only goes up to 15. So we don't know what f of 38 is because this graph only goes up to 15. So what you can do is you can say, well, we don't know what f of 38 is, but because the period is 4, we know that that has to be the same as f of 34. Now, f of 34 is also not on the graph. So if you subtract 4, because that's the period, that's the same as f of 30. So basically, you subtract the period until you can see the point on the graph. All right, can't see 30, so we look at 26. We have to go all the way down until we get to at least 15 or lower. So the next would be f of 22. The next one would be f of 18. And the next one would be f of 14. So 14 we would be able to see on the graph. There's 14. So the point here, this is f of 14, which would be the same as f of 38. So that value is equal to -2. Now, there is a faster way to get this answer without having to do all of this work. It's a little more abstract, so it's up to you which way you'd rather do it. What you could do is you could say, we're looking for f of 38. The period is 4, so if we divide 38 by 4, we get 9. And that is the number of full cycles. There would be 9 full cycles and then some partial cycles. So if there's 9 full cycles and each cycle is worth 4 units, that makes 36 units in total. And if you take 38 and you subtract 36, you get 2. So that means f of 38 would also be equal to f of 2. And you can see f of 2 is also down here at -2. So that's just an optional way of doing this question. You don't need to know this way. If this way didn't make sense, you can just figure out this way by taking whatever that value is and keep subtracting the period. So the period is 4. So subtract 4, because every 4 units you're going to get the same value because it's a periodic graph. And you keep going until you can see the number on the grid. And once you can see the x value on the grid, then you can figure out the y value, and that gives you the answer. So this is all the terminology and basic knowledge you need to know about periodic functions. Now this unit, sine functions. Sine function is a special type of periodic function, so we need to learn what periodic functions are before we get to sine functions.